Do muscles really have memories? Dr. Miller here with a little bit of information download for you. Sorry for the hole in my wall. Check that out, right? I think it just kind of goes with the whole um, kind of vibe, right? You know, I'm a hardcore exercise science, strength conditioning minded guy, and I have a hole in my drywall in my wall. That just seems pretty cool. Anyway, that's besides the point. Let's stay on track here. Does muscle have memory? Does skeletal muscle have memory? You hear that quite a bit, right? In the strength conditioning circle, in the sports performance circles, and personal training, whatever. You know, well, if you do this and you learn how to do it, your muscles will have these memories about how to perform a pattern. That's what the definition usually is. You know, I think of an old boxer I met years ago in his 60s, and you know, he was kind of talking to me and started getting into what he was talking about. Started throwing some punches. Now he didn't hit me with them, thank goodness. He still would have probably knocked me out. But you could, I mean, he was fast, right? His hands were quick. He was incredibly efficient. He was technical in his movements. He understood the kinetic chain. I mean, it was impressive to watch. Now, did that come from his muscles? No. And that's kind of what the point of this. Now, this is information. It's like, well, who cares? I mean, it's just somebody saying something. What's the big deal? And you know, am I really going to be the jerk at the party that corrects somebody's? Well, it's not really muscle memory. What, you know? No, but what is important in this conversation is understanding, well, if it's not the muscles, then what is it? And if patterning is important, how do I develop them then? And then how do I make the pattern better? Okay, and so you know, on the surface it seems like, well, who cares? Just some semantics a little bit, but it's more than that. Okay, it's more than that. It's understanding, you know, how the body adapts and then to write better programs potentially. Because if we're, you know, we might be talking about sports skill, but we also be talking about getting stronger or perfecting a movement pattern in the gym. Okay, so what is muscle memory then? Is there such a thing? Well, I would say there is. So let's start there. What is muscle memory? Muscle memory, and the way I would define that is when muscles get bigger, there's more nuclei that are associated with muscle fiber. Now, there's some debate about what happens first. Is there more nuclei than the fiber or more fiber than the nuclei? The way muscle fibers work is unlike the cell that you might learn about in basic bio class, looks like an egg. When it splits, that cell, the one in bio, it splits its contents and the nuclei, right? Mitosis. And so we have this replication of the cell. That's how it gets smaller and manages itself. The cell can only get so big, and the nucleus is like, that's too much. I just can't manage that anymore. That's split. That's split up. That way, nuclei for each cell, smaller cell, I can manage that. That's how we manage growth. Okay, in many cells. In skeletal muscle cells, we don't do that. We have hypertrophy, so the cell gets bigger, but it doesn't split. So the strategy of a muscle fiber then with the same problem was, well, how do I manage all this growth? How do I manage these areas of this fiber? Is that instead of splitting the cell, I'm just going to add more nuclei. Okay, I'm going to add another nucleus if I wanted to add one. Okay, I'm going to add it in there. I'm going to take these satellite cells and I'm going to run it through a process that, you know, it's been exposed to all these biochemical signals, and I'm going to make, or basically bring about, from a satellite cell another a nucleus, and add more nuclei over time in order to manage the growth of the cell. And the argument is this nuclear domain theory. The argument is, you know, what happens first? Do we need the nuclei, then the fiber grows, or does the fiber grow, then nuclei come about, or they happen at the same time? More than likely, it's probably some combination, and it's probably differential between situations, and maybe muscle fibers and the sex of the individual and aging and all those things play into this, but more than likely they kind of run together, right? The fiber gets a little bigger, that's a signal, and it's also been started, this signaling, to make more nuclei, and oh, the fiber's going and is getting bigger. Well, let's add the nuclei then, okay? And then we build it up over time. We have this growth in both the amount of nuclei and the actual fiber, the cross-bridging and all those things that are responsible for exerting force, and the supportive tissues that are associated, okay? And so when, though, we grow, when hypertrophy occurs, the nuclei are increased. So regardless of, you know, how or when, and that's again debatable, they are increased. Now, some have even said that maybe that is not true as well, but and this is maybe a little more opinion based on the research I've seen and the way I interpret it. So you can interpret it as you like, as these nuclei are on board. And once, or if atrophy occurs, in other words, the fiber gets smaller, these nuclei are going to linger, okay? And so you have this higher density of nuclei in the fiber. Now, as we age, these nuclei actually appear to go away, which is one of the reasons we have this event of sarcopenia. We have muscle wasting occur as we age. It's because these nuclei disappear, and if you disappear and you can't make new ones, if you will, if you can't proliferate them, these satellite cells into nuclei anymore, or at least not very efficiently as we age. And a lot of that is just activity, right? We don't lift weights, you use it or you lose it. Then you start to see a decline in muscle fiber. Now there's other factors here. Of course, sarcopenia is not just that, right? There's endocrine responses, and of course there's sociological things. It could be even somebody has the inability to chew food effectively anymore, and so their protein intake. I mean, there's so many factors here. I don't want to make this too simplistic. But the point for this video is that these nuclei are on board. And so once they're there, they're there. Okay. Now this also speaks to, athletes that have abused drugs and then serve a suspension and come back. It's not like those muscles are like, you know what, yeah, that was wrong. Let's go and offload all these nuclei and these extra, cross-bridging material, right? So, actinomyosin, these sarcomeres, let's just go and just strip those off because that wasn't fair. We'll revert back to our pre-anabolic steroid use. That's just ridiculous, okay? So that's here and there. It's more of an ethical question, but I think understanding muscle memory, though, is what I'm getting at. That's important, right? If you're talking about muscle memory, well, muscles remember when they were bigger, and they've been forever altered by anabolic steroid exposure. And we're talking about trying to equal the playing field for sport, which is, I think, just a never-ending, chasing the rabbit down the hole experience. But if you do this, then that's important to understand muscle memory. Like these athletes that serve a 2 or 4 year suspension, in terms of their performance when they come back, they're still going to be a superior athlete compared to those who never did anabolic steroids. Okay, or at least they're going to be a superior athlete to what they would have been before they did anabolic steroids. Okay, so muscle memory. Now, if we look at muscle memory in terms of the way people define it, what is muscle memory then? If it's not the muscles themselves, well, muscles do what they're told. And who tells the muscles what to do? The neurological system. The neurological system is what really is what most people define as muscle memory. So it's, if you want to be that guy at the party or the girl at the party, is like, well, excuse me, it's not really muscle memory. It's actually neurological memory, right? And then nobody wants to talk to you anymore, and that's fine. It probably wasn't that cool of a party anyway, because they don't understand physiology. And those are the parties you really want to be at, because those are going to be more fun, because you have more really in-depth conversations about nuclear domain theory and things like this. And so the neurological system knows what houses it. When that boxer threw that punch, what he was executing was a highly myelinated circuit that he had thrown, I don't know how many punches in his life, but that circuit was developed, and each pattern has its own, right? So he's throwing jabs. He has a jab circuit developed. Now, where is that circuit? Well, it runs all the way through his neurological system. The cerebellum stores a lot of our patterning and cleaning up the patterns that are associated with movement. And I always joke with athletes, live out of your brainstem and not your frontal cortex, right? I want you to live out of your brainstem. If you think about some of the amazing moments in sports, now, not all of them, so I'm cherry picking here, okay? I can speak from my own experience as well. Like when somebody's been sick, like I remember being sick when I was in college for a big game. And we still got trashed. But anyway, I had a great game because I was like, I'm sick. Oh, I just don't feel good. And I went out there and just played. I didn't really think about anything. I lived out of my brainstem. I let my body move. We talk about the zone and the flow, these phenomenon in sport. That's essentially what's happening is you've removed the barrier of your brain, your frontal cortex, from taking over and overthinking things. You're just living out of a pattern. You're living out of the brainstem. I think of these studies that I've done in cats. I'm sorry if you like cats, but when they severed their brain, or when they severed their spinal cord, and these cats can still run, okay, on a treadmill. So they've lost this higher executive function from their brain, but they're basically living out of their brainstem, okay? And so when we talk about muscle memory, that's what we're really talking about, is the neurological system. And so what that means is when you're trying to build patterns, what you're actually building is patterns. Right? That's exactly what you're doing. Then you're trying to myelinate it. You're trying to make it so that pattern is executed at the highest rate possible. And that's what a coach will try to do, is try to build constraints, and whether it's through cues or through actual devices or whatever it is, to create a new pattern at high velocities, or timing of high velocities, whatever it may be. Okay? I don't know if dart players, they need some velocity, right? I mean, that's legit. So how does this all culminate then together? Well, if muscles are at the end of the neurological system, the more force that they exert, the the better output is going to be of the pattern. The better the neurological system, the more efficient the pattern, and the more efficient in the movement. And so, if you have a person who has fiber types that fit a particular movement really well in a particular muscle group, so let's say they're a lot of type 2 fiber, and it's a sport that requires high power output, and then they have a heavily myelinated neurological system that's leading to it, and a very high neuro drive. And there's other factors, of course, nutrition and connective tissue quality, all these other things. But if you just think of these two pieces, now you have somebody who's pretty impressive. That boxer, going back to that example, he could throw a really efficient punch. Like his circuit was amazing. It's still myelinated, fantastic. But if he hit me in the face, he'd still inflict a lot of damage in his mid-60s, but not near like he would in his mid-20s. He would knock me out in a second. However long it would take from that transmission of force to my skull, that would be how long it took to knock me out. In his 20s, maybe in his 60s, I could take a couple blows before, I finally wilt like a little flower. So what changed? Well, the muscle, right? The muscle's not as big. It doesn't have as much cross-section area. It doesn't have as much, force capabilities, but the pattern and the technique was still good. Okay. So again, it's like, well, who cares? Muscle memory, it's misnamed, whatever. Well, if you really want to think about the physiology behind this idea of muscle memory, though, it also can help you understand how to train people better. It's not the muscles themselves that matter. The pattern, the neurological system has the pattern, myelinate the pattern, create the good pattern, create the right circuit, then make the muscles bigger. Then they come together, and obviously they're interacting together to produce superior movement. So that would be my interpretation of muscle memory. Now you can go be that jerk at the party.